Good day to the examiners. I'm Tan Shi Xuan under the supervision of Dr. Ida. Today I'm going to present my final year project with the title of Augmented Reality Board Game using hand gesture interaction on handheld device. The aim of this project is to develop an augmented reality board game in handheld device with hand gesture interaction. There are several problems were found. When using AR application, a displaying device is needed, and HMD is one of the choice. However, HMD is uncomfortable and not ready for the mass production for the market. And current application focus more on displaying but not the interaction. The third, when interact with the game object, they might be too small to be clicked via the touch screen. And last, touch screen may cause shaking of the camera, thus reducing the AR tracking efficiency. There are three objectives in this project. The first is to determine how hand gesture interactions can be used in playing AR Chinese chess board game. To design and develop a Chinese chess board game using AR with hand gesture interaction, and to evaluate hand gesture interaction on AR Chinese board game. There are only 4 scopes in this project. It must be an Android-based application on handheld device. Android smartphone with minimum 8.0 API level and supported by AR Core. Single player, and the user needs a plane surface. The literature review has achieved the objective 1. There are 4 main topics we'll review: AR tracking method, AR displaying device, AR interaction method, and the board game, which is Chinese chess. The methodology has achieved the objective number 2, and in this project I have 4 phases, which is analysis, design, development, and evaluation. The board game development including the UI, and it has 2 sides, which is black and red. It's a turn-taking game, but due to it was single player, so an AI opponent was implemented with minimax algorithm and alpha beta pruning. Here's a whole UML diagram of this project. So the chessboard here is the main class that will control almost everything of the game. And the chessman class is an abstract class that was inherited by every chess pieces and also the tree structure, which is the AI. Move class store the chess piece that's going to move for the AI opponent, and AR tap to place object is for placing the object when the plan is detected. And board highlight shows the possible move when a chess piece was selected. The project framework is shown as the figure. So there are few main things. One is the plan detection of the AR. Then button motion is used to perform the hand gesture recognition. And the main thing is the game, which includes the chessboard, chess pieces, AI opponent, and hand gesture interaction. To interact with the chess pieces, coordinate mapping is required. Implementation also achieved the objective 2. The implementation of augmented reality requires a few packages, and the main are the AR Foundation and AR Core. For the plan detection function, AR Foundation prepare a script called AR Plan Manager. You just drag into your AR session origin, which is the camera, and you place your plan prefab that is going to spawn notification like this, and you choose your detection mode. The placing of the game object, the user move around the camera, so when a plan is detected, it will show as figure, and the user can tap on the screen to perform ray casting by using AR Raycast Manager. And if the ray intersects the plan, it will spawn the chessboard. The implementation of the Chinese chess. So here's the chess piece model used. So I downloaded it from the website and it is free. So the chessboard is drawn by myself. The flow chart here shows the flow of the Chinese chess game. The chessman abstract class is inherited by every Chinese chess pieces, and there are some important functions. Set position is set the position of every chess piece, and the set before position is used when AI opponent calculates the best move. And set original position is used when one side wins the game. Then possible move is to show the valid destination for every chess piece. Here's a UML diagram of the main class, which is called chessboard. It controls almost everything. The main function are chess piece selection and chess piece movement, and calculates AI movement, and also move to original position when one side wins the game. The hand gesture interaction was implemented by using the SDK called Monomotion. The major problem faced is the coordinate problem. Monomotion provides the coordinate of the pinch point here, but it is in viewport coordinate. So viewport coordinate only 0 to 1, and due to some reasons, the usable range is only 0.1 to 0.9, which is not suitable for this project. So Unity provides a function called viewport to screen point to convert the viewport coordinate to screen coordinate. And the screen coordinate was used to perform raycasting, which is used when selecting the chess pieces. Due to the application is single player, so an AI opponent is needed. First step, here's the piece value of every chess piece, and it was based on their strength. The position value is the value of the chess pieces in certain position. The piece value and the position value is used to calculate the board value by using a formula shown. The calculated board value was used to perform the minimax algorithm and alpha beta pruning. The next step is to construct the tree structures. So the current array, which is the current game board. So the possible move for the next is the chariot, then the chariot possible move too. So the one parent will have very large number of children. AI opponent was implemented by using the minimax algorithm and alpha beta pruning. At the left side is the pseudocode, and at the bottom here shows the explanation of the alpha beta pruning. So when these nodes must be greater than or equal than 5, and while the parents here is to get a minimize, so we don't have to search down and reduce some computational time. Evaluation has achieved the objective tree. So here's the experimental setup. We need a user is holding a handheld device. Here's the hand gesture and a plane, like table or floor. So the usability testing was carried out by 5 male and 3 female at 24 years old. All of the respondents have experience with AR, and most of them consider themselves as intermediate level. There are 6 of them have experience interacting game object with hand gestures, and most of them consider themselves as in the intermediate level. Based on result, every respondent used external device when interacting with digital content, and the no here is due to the technical problem of the questionnaire. So post-experiment questionnaire was given after a user tested the game. The game user interface is clear and easy to interact with because the results were distributed evenly at a scale of 4 and 5. Almost all of the respondents either agree or strongly agree that the plan detection before placing the chessboard is effective. The respondent either agree or strongly agree that the chessboard players can be seen clearly. Only one of the respondents disagree that the chess pieces can be differentiated easily by their color and border. Here's the hand gesture interaction part. The click gesture can be detected effectively, and it is agreed by 4 respondents and strongly agreed by 3 respondents. The pick gesture can be detected effectively, only receive 1 neutral vote from the respondent. The drop gesture can be detected effectively, receive 2 neutral votes from the respondents. The chess pieces can be interacted with hand gesture effectively. 4 respondents agree with this statement, and 2 respondents strongly agree with this statement. The chess pieces can be interacted with tapping on smart screen effectively, agreed by 4 respondents and strongly agreed by 3 respondents. So after testing the game, it was a tie between the preference of the interaction methods, which are tapping and hand gesture, However, overall, the respondent had more interest in playing the game by using hand gesture without any external device, as answered by 100% of the user. Lastly, all of the respondents prefer bare hand gesture interaction compared with hand gesture interaction with an external device. This feedback from the user strongly suggests that users very much enjoy the immersive experience through AR hand gesture interaction while playing Chinese chess game. Here's the user acceptance testing. There are some features that are not discovered by the user, but these functions are not necessary as they do not affect the gameplay and testing. Conclusion. The first objective was achieved in literature review part. The second objective was achieved in methodology and implementation. The third objective was achieved in the evaluation part. The first problem was solved by using a handheld device as the display device of AR applications. And the second, third, and fourth problem was solved by using hand gesture interaction. And this project has successfully implemented AR board game development with the following elements, with AI opponent using minimax and alpha beta pruning algorithm. So to summarize, the project augmented reality tracking technique is plan detection, and the user can tap on the screen to place the game board. And the board game is Chinese chess. It has black and red side. It's a turn-taking game and single player, so an AI opponent was implemented. Hand gesture interaction was implemented by using monomotion, and there are 3 gestures by using pinch, and simple UI was implemented as well. There are some enhancements that can be done in the future. The first one is the multiplayer, because the current application only supports single player. And the AI opponent enhancement, because the current algorithm used was very simple, very basic minimax algorithm and alpha beta pruning. In the future, a chess engine can be used, and so the AI opponent may be more challenging. Since the title of this project is augmented reality board game, so more board games can be implemented, since not everyone likes to play Chinese chess. The chess piece model can be remodeled, as one of the respondents disagree that the chess piece model can be differentiated easily by the model and the color. From the comment below, in the future the hand gesture interaction accuracy can be increased as well. As a reference. Thank you. That's all from me.